So now there's something else. So the Coriolis effect, it has it affects ocean circulation patterns, but there's something more that also generates or drives ocean circulation patterns, and it's heat. So if this is the Earth, and you have the sun here. So at the equator, you're going to get the most amount of sunlight. So at the equator is going to be the hottest region. And at the poles, the sunlight is going to pass, but it's just going to be glancing sunlight. So because of that, at the poles, it's going to be colder. So something else that drives ocean currents is anytime you have a temperature difference, whether it's air or it's water, the water is always going to flow from hot to cold. So this is actually the driving force. This is what kicks off ocean circulation patterns, is that the hot water at the equator wants to move north towards the poles, but as it tries to move north, the Coriolis effect causes it to deflect towards the right. But one of the main drivers is just this idea that warm currents always want to move north towards the poles. So warm currents try to move north towards the poles. Well, let's just say towards the poles, North Pole or the South Pole. Warm currents always want to go to where it's cold. So warm currents always move towards the poles. So you can see here warm current going from the northern hemisphere towards the poles here, and from the southern hemisphere, let's see if you can pick one here. So well, you can see one here, from South America down to the southern pole. And what this has a very important effect for life in different places on the globe. So let's see what what effects these global ocean circulation patterns have for people around the globe, or life around the globe. So you're looking at, let's look at this map here, and those two lines show you that this is London here, and at the same latitude, this is around Nova Scotia. And what you find is that London is relatively warm, but at the same latitude in Nova Scotia, it's freezing here. And if you look at the ocean circulation patterns, we can see the reason why is that warm currents from the equator start at the Gulf Stream, and they because they're warm, they try to move north. But as they try to move north, the Coriolis effect deflects them towards the right and towards Europe. And so these warm currents pass by Europe, and as they do, they release that heat into the atmosphere, and that allows Europe here to be warmer than it would be. So, after that, the ocean currents pass towards the poles, and as they do, they cool down, and as they pass towards Canada, Nova Scotia, this area here, it cools this area down. So depending on what ocean current you're by, your temperatures are going to get affected. So one major effect is this then, is that, well, let's even look at this, a more familiar example. So London is up here, New York City is down here. And what you find is that even though London is farther north, on average, it's warmer than New York City. And the reason why is that it's getting these warm waters that are passing by it, whereas New York City is getting more colder waters that are passing by it. So on average, London is going to be about 8 degrees warmer than New York City. 8 degrees Fahrenheit warmer than New York City. Even though New York City is farther down and closer to the equator. And the same thing happens in California. So if you look on the East Coast here versus the West Coast, so by the East Coast you have this warm circulation pattern or ocean current that's passing by, And on the west coast, you have a cold current that's passing by. And what you find is, again, at around the same latitude, so in this case here, Northern California versus the East Coast, you find that because there's a cold current passing by Northern California, it's going to be colder than the East Coast at the same latitude. So Northern California is about 10 degrees warmer, 10 degrees Fahrenheit, cooler, 10 degrees Fahrenheit cooler than the East Coast. So the East Coast and Europe. And it's because of these global or ocean circulation patterns. Here we're going to look at another concept. So here, let's say that this is the coast of Africa, and it goes down to the bottom of the ocean, and this is the water here. So this is the water. So what's something that is always happening, well, is that the sun shines. And what the sun is going to do is it's going to heat up the surface of the ocean. So the ocean surface is going to be hot. And at the same time, the bottom of the ocean is going to be cold. So it's going to be full of cold water. And so that's if just what happens in general. But now let's say that this location, well, if you're looking at here, there's a prevailing wind off the coast of Africa, and let's see what effect this is going to have. So we have this prevailing wind that is constantly blowing from onshore to offshore. And what the wind is going to do is it's going to grab that warm water and it's going to drag it along with it. So as the wind blows, it's going to take the warm water with it, and it's going to push it to the right. So it's going to push it away from shore. So this is kind of hard to draw. So let me see if I can let's see if this will work here. So it'll grab onto the warm water and push it towards the left here. So the prevailing wind is going to push the warm water away from the shore. But at the same time, water level has to stay constant, so whatever water leaves has to get replaced. And that warm water then is going to get replaced by cold water that's going to be sucked up from the bottom of the ocean towards the surface. So what's going to happen is that the cold water is going to flow up to the surface here. So this is called upwelling. So this is upwelling. So upwelling is that the ocean surface, well, let me just write this as I see it here. So we have wind that's going to blow from onshore to offshore. So from onshore to offshore. And as it does, it blows away the warm surface water, and it pushes away the warm surface water. So it pushes away the warm surface water. And as that warm surface water is displaced, then that water has to get replaced, and it gets replaced by cold water. But there's something more here. When we looked at plate tectonics, we said that all mountains eventually crumble to dust, and that dust and all the fossils and sediment wind up as horizontal layers at the bottom of the ocean. When we looked at the different kinds of rocks and also plate tectonics. So the bottom of the ocean it's full, it has a thick layer of sediment, and the sediment is not just dirt or debris, it's full of nutrients, like it has iron and copper, and it has fossil remains. So there are minerals in this sediment here. And the upwelling, so when upwelling occurs, you don't just have cold water that is pulled upwards from the bottom of the ocean, but those same minerals like the iron and nitrogen and copper and whatever else, all those minerals get drawn up as well. So these upwelling is when it's full of nutrients. So upwelling contains large amounts of let's just write it here. So upwelling contains large amounts of nutrients. That are dissolved in the water. And we can, so now during these upwelling events, what we find is that these nutrients, animals can feed on these, bacteria feed on these, and fish feed on, smaller animals feed on the bacteria, and fish feed on those animals. So you have a lot of photosynthesis happening here, and as well. And this is what this picture shows you here, is that there's an upwelling that is occurring off the coast of South Africa here. And this is showing you a graph of the amount of photosynthesis. And you can see that you're getting a lot of photosynthesis here because there's a lot of nutrients being drawn up from the bottom of the ocean, and animals can feed on those nutrients, and so they kicks off a larger amount of photosynthesis. So upwelling is going to be an important process, an important side effect of these global ocean circulation patterns. So that means that whenever you have these upwellings, you're also going to find a lot of fish, so a lot of food.